Hello, my name is Hunter Gibson, and this is the digital to analog audio converter. And here's a test of the final project with better quality.
Testing 1 2 3. Hello, hello. Testing 1 2 1 2 3 1 2 3. Hello, hello. Testing audio playback device. Testing.
The goal of this project is to take digital audio data stored in a .wav file and convert it into an analog signal that can be played through a speaker. This process focuses on utilizing digital outputs to simulate analog waveforms and amplify the signal to drive a speaker effectively. Let's dive into how it works. To start, let's explore the foundation of this digital audio. A .wav file stores sound as a sequence of numbers representing the amplitude of sound waves at regular intervals. In this project, I use 8-bit uncompressed .wav files sampled at 8 kHz. This means that 8,000 amplitude values are recorded per second to represent the audio. The library extracts each amplitude value and converts it into a square wave using pulse width modulation, or PWM. PWM is a method of representing an analog signal by rapidly switching a digital output between high and low states. The length of time the signal stays high, known as the duty cycle, determines the perceived amplitude. For example, a higher amplitude corresponds to a longer high state in each cycle. The Arduino outputs this PWM signal, which is then amplified and sent to the speaker. Because the Arduino Nano's output is limited to a few milliamps, it isn't powerful enough to directly drive the speaker effectively. That's where the 2N3904 NPN transistor comes in. The transistor acts as a current amplifier. Its base is connected to a PWM signal from the Arduino through a resistor to limit current. All the parts of the system work together to achieve real-time audio playback. The Arduino Nano processes the .wav file stored on the SD card, generating a PWM signal for each sample. This signal is then amplified by the 2N3904 transistor, which powers the speaker to produce sound. This project demonstrates how digital audio data can be processed and amplified with minimal components. By combining the Arduino's processing capabilities with a simple transistor amplifier, I created a functional audio playback device that highlights the core principles of digital to analog conversion and signal amplification.